at a problem. So 3 or 4 will be 0, and here it is minus 0.48. Of 5 is minus 0.64, 0.48, 0, 0, 4, and 3 will be minus 0.48, 4 and 4 will be 0.36, 4 and 5 is 0.48 minus 0.36. 3 is minus 0.64, 0.48, 5 and 5 is this 0.64, and 5 and 6 is this value minus 0.48. 6 and 3 is minus 0.48, 6 and 4 is minus 0.36, 6 and 5 is minus 0.48, 6 and 6 is 0.36. So this is how we get the global stiffness matrix of size 6 by 6. Now, as we have assembled the global stiffness matrix, the next step is to find out the displacements. Now we know that nodes 1 and 3 are hinged and both will not allow either horizontal or vertical displacements. So we have to eliminate from this stiffness matrix the degrees of freedom corresponding to nodes 1 and 3. So node 1 has a degree of freedom 1 at Q1 and Q2. So we have to eliminate this row as well as this and this. And node 3 has a degrees of freedom 5 and 6. So column 5, column 6, row 5, row 6 is eliminated. So when we are writing in the form KQ equals to F, we will have left with only a 2 by 2 matrix minus 0.48 and 0.36. Now this corresponds to the degrees of freedom 3 and 4, which are of the node 2. So here we will have Q3 and Q4. Again, now the force terms that we are writing here has to be of node 2 only. If we go back to the problem and see in the horizontal direction, okay, that is in the 3 direction, we don't have any force applied, but in the 4 direction, we have a force, downward force of 12 kilonewton applied. So let us in this vector write 0 because in the 3 direction there is no force, whereas in the y direction there is a force of 12 kilonewton, which is 12,000 newton, and we are using the negative sign because it is downward. So when we solve these equations simultaneously, we get that we have missed this AE upon L. So we need to substitute for A, which is given as 200 mm square. The Young's modulus is given as 70 into 10 to the power 3 Newton per mm square, and the length of each element is 500. and we get Q3 as 0.57 mm and Q4 equals to 1.93 mm. Next, we are asked to find out the reactions. To find out the reactions, we are going to use this equation. Okay, so the reactions are R1, R2, R3, R4, R5 and R6. This K matrix that we're talking about is the 6 by 6 matrix that we had derived earlier. So I'm rewriting it. It's 1, 0, minus 1, 0, 0. This is from Q1 to Q6. So we have 0, 0, 7, 1.95, 0, 0, minus F, minus 12,000 in place of F4, and the remaining are all zeros in the first vector. So if we need to get reaction 1, we will say R1 equals to this first row multiplied by the Q vector here we have a term of 28 into 10 to the power 3, that is AE by L, minus F. So K into Q minus F.